CG. What is it? The center of gravity, CG, is considered the null point of action of the various gravitational forces acting on an element with its own mass. The CG is also considered a point of balance. Both lateral and longitudinal balance are important, but the main concern is the location of the CG along the longitudinal axis. Its importance lies in that the stability of the aircraft depends on it. The CG is not necessarily a fixed point, its location depends on the distribution of weight in the aircraft. As cargo items are shifted or consumed, there is a change in the location of the center of gravity. Each weight multiplied by its arm results in a moment. Taking this formula into account, we can use two of the three variables to calculate the third. In measuring the arm, the sign is positive if the measurement is behind the datum, and negative if measured in front of the datum. In the following graphs, we will see how these concepts come into play to locate the CG and the desired balance. In the first one, we see how the datum is established right in the middle. This is for practical purposes, not necessarily the case in airplanes. Likewise, the load is 10 kilograms on both sides of the datum, and exactly the same distance from the datum, arm, which is why the CG would be located in the middle, right on the datum. In the second graph we have two different loads. On one side of the datum we have 10 kilograms, while on the other side we have 30 kilograms. Now if we want to keep the CG in the middle, we must play with the other variable, arm. So, if on one side of the datum we have 10 kilograms and an arm of minus 30, the moment will be minus 300. If on the other side we have a load of 30 kilograms, and we want to reach a moment of 300 to keep the CG in its initial location, then the other variable, that is the arm, must necessarily be 10. In this third example we have a load of 10 kilograms on one side of the datum and an arm of minus 30, and on the other side a load of 20 kilograms and an arm of 30. Thus in the first case we will have a moment of minus 300, and on the other side a moment of 600. Therefore to determine the CG, we add both moments, minus 300 plus 600, and divide by the total weights, 10 plus 20. This way we obtain the location of the CG, 10. With these simple examples we realize that by mastering these three variables, weight, arm and moment, we can control the topic. And knowing two of these three variables we can solve any problem presented. Next we will see the consequences of a forward CG and an aft CG. It is important to note that the natural correction for a longitudinal imbalance by the pilot is a compensation change to remove excessive pressure on the control. Excessive compensation, however, has the effect of reducing not only aerodynamic efficiency, but also the range of travel of the primary control in the direction in which the compensation is applied. Forward CG consequences. The aircraft tends to become nose-heavy, positive for avoiding stalling, but has other negative implications detailed below. The use of flaps at low speed can increase the tendency for the aircraft to pitch down. Changing attitude in the event of a missed approach will be more difficult. Flaring the aircraft during landing will be more difficult. Higher angle of attack required to maintain altitude. Lower cruising speed. The aircraft stalls at a higher speed. Aft CG consequences. During takeoff the aircraft may tend to rotate prematurely. During the climb phase the aircraft tends to have a higher angle of attack. The aircraft becomes unstable, especially at low speeds. Danger of violent stall, lower stall speed but greater difficulty in recovering the aircraft.